Welcome to Modern Software Engineering, where we talk about stuff that software developers and other technical type people should care about. If you like the content that you see here, then hit like. And if you want to see more, then you should subscribe. Today, we're doing one big question, another one big question. This is a fairly new series that we've started where we're going to explore one topic between two of us, and we're going to hopefully go in a little bit of depth, but also have a conversation about it. So we are going to, and hopefully we'll come to some sort of resolution at the end of it. We'll ask a question. At the end, we should have a resolution, which will probably be, it depends. So if you like this content, as I said, like and subscribe, etc., etc. I'm Trisha Gee. I've been presenting on the Modern Software Engineering channel for a couple of years maybe, back when it was continuous delivery, and now it's Modern Software Engineering. I am a developer advocate. I've been a Java developer for a bunch of years, and I'm mostly just an opinionated person, and that's what qualifies me to be on this channel. Joining me today is Steve Smith. Steve, tell us a bit about yourself.
I'm Steve Smith. I'm Cornish. I'm the Global Head of Modernization and Platforms at Equal Experts. I was a Java developer for many years. I worked with Trish. She's far too modest to mention that she was like a really awesome developer that we all aspire to work with Dave Farley too at LMAX. And I'm now an engineering advisor. So I spend my time talking to CTOs and VPs about what good engineering looks like.
I feel like I should talk to you about what good engineering looks like, but maybe we'll discuss this on today's topic. So today's one big question is, will AI create mountains of technical debt? Which I was really excited to talk to you about because I think this is a question which has been preying on my mind. So initial thoughts, do you think AI is going to create loads of technical debt?
Yes, that's the end of the conversation.
Let's cut the conversation. That's it. Well done.
I'm a big believer in Betteridge's law of headlines. Like any headline that ends with, will this result in a mountain of blah, blah, blah? The answer should be no. Like every question, a headline can be answered with no. But on this case, I think this is an exception. I don't see how it can't happen. I think that it'll be easy to get out of it, hopefully. But I think it's kind of inevitable. Why do you think it might end on, why would this end on it depends, Trish?
I mean, it depends as a general answer to a lot of questions. Generally, in this particular question, I'm inclined to violently agree with you that it will create lots of technical debt. So I kind of wanted to be a bit more of a devil's advocate and explore some of the other sides of things. But I'm inclined to agree with you because for two main reasons. One, AI will generate a lot more code a lot faster. So statistically speaking, there will be more tech debt. And two, at the moment, the stage that Gen AI is at, the quality of the code that is generated is by default not the standard I would like to see. So my thoughts are, yes, we'll get a lot more tech debt a lot quicker.
Yeah, I think that the tools like Cursor and Windsurf are immature, but I think they're also really exciting. I've seen some teams pull off miracles with them. I've seen teams get into tricky situations with them. I try to describe Gen AI to customers as rocket fuel. In other words, if you already are in a great situation, it's going to make things amazing. If you're already in a bad situation, then it's going to make things much worse. And I've definitely seen, it depends on how you train the AI, like so many things. And I think what people are learning is if you are already someone who's really experienced and comfortable with pair programming, like you and I, if you're someone who's really comfortable working in small increments and working off trunk, then it's going to be just fine. Yesterday, for example, I worked with ChatGPT. Sounds weird to say that even now. I paired with ChatGPT to generate a JavaScript to sync parts of one Google Calendar into another, something that is absurdly complicated in the UI. And I'm really, really bad at JavaScript. And yet within an hour, we had something, it even sounds weird to say there was something that worked and was good enough. And it did involve lots of manual testing, and the AI got confused a couple of times. But because I have trained the AI on the things that matter to me most as an individual, it worked out pretty well. But obviously that was software being generated for an individual, not for a company with actual live customers, where I think the training is going to be much harder.
And you raise a good point there. This is one of the things I wanted to talk about. The assumption I have made is that by default, the Gen AI tools tend to generate code that I do not like. So how can we get the AI tools to not generate technical debt? How can we get them to create code that meets our criteria?
So if we think about technical debt as code that's unreasonably hard to change, perhaps, then maybe it's kind of inevitable to an extent with AI. I think that with good training, with good technical alignment between different engineers in the same team, in the same department, guidelines come from leadership on this is what good engineering looks like for this company, then I think it could be pulled off. Like in the noughties, tools like Checkstar were all the rage to actually understand or enforce this is what good code looks like in this company. I can totally see a world now in which, you just chuck your Checkstar file into Cursor or Windsurf and says, this is what we want it to look like. It will help to an extent. I can still see a lot of code being produced that's hard to change. The question that's going to come up is, when does that matter? I think there will be times where it doesn't matter. My JavaScript example, the code is probably garbage. If I showed it to someone who actually understands JavaScript, they'd probably tut. But it's good enough for the thing I needed it for. But what do you think, Trish?
Yeah, I think you're absolutely right. And I think this kind of steers me to something else I wanted to talk about, which is, when do we need to pay off tech debt? But before we even get to that point, like what is tech debt? What does tech debt look like?
So I actually actively avoid talking about tech debt with engineers and customers now. I think that it's such a hard to understand, overloaded term. Like there are so many analogies I've heard over the years, like the credit card one is probably the least worst analogy. I would just say code that's slow to change, hard to change, risky to change. But even that is a little complicated, because in any amazing service that we crank out tomorrow to run on the latest tech stack on Lambda, there's still going to be corners of the code that you aren't super happy with and are a bit messy. I remember I was working with LMAX back in 2008, and there was like a giant whiteboard that went the entire wall of the office. And one section of the whiteboard, we had like a list of the big refactorings we wanted to do. And the idea was that whenever a developer on the team touched an area of the code base near one of those, you would devote a little bit of time to it. I thought that was a really great way of handling it, but it wasn't called the tech debt list. I think it was called the refactoring list. But that's really what it was. It was about incrementally fixing the situation as you go along. I don't think that's going to be the same world now if we're generating a service together with AI.
Yeah, I think, yes, it could be true. The way I read Kent Beck's Tidy First book, and it made me start thinking quite differently about what we had been calling tech debt, in terms of like, when do we start paying it off? Do we need to refactor? Do we need to make these changes? And when is a good time to do those things? I do feel a bit like with some of the AI code that gets generated, my instinct is there are some cases like the one you just talked about where we'll generate it, it does a job, it's kind of fine, you won't need to change it, or you won't need to change it much in the future, and you can just sort of treat it as a black box. So maybe we don't care that it's full of tech debt, because it's not really debt if you're not paying a price on it.
Yeah, so if we use an analogy that we're both familiar with, from LMAX, the trading exchange we both built together, there were many different, well, you probably call them microservices now, although they were pretty chunky, and there was an execution venue that was incredibly high performance, and every line of code mattered hugely to the entire company as a whole. How fast, I think we had to have order matching under 10 milliseconds, if I remember rightly.
That's correct, yeah.
So that's going to be handcrafted. However, my team was also responsible for building a trade reporting gateway, which was essentially a translation service where you feed in some orders and it spits out information to different consumers of trade reporting in the financial industry. I can totally imagine us generating that with AI, the trade reporting gateway. Mm-hmm. I did wrestle with this recently. I did start to think about, what have I worked on in the past that really was value add, that really mattered to the company? Like the first time I saw Cursor generate build scripts and deployment stuff, I felt a bit heartbroken and thought, that's a year of that one Gradle script it just created, or that one GitHub action it's just created, that's a year of my career learning that and honing that, perfecting that, and that's gone in like 10 seconds.
But I quite like that to some extent, yes. But I quite like that there are some parts of the things that we've learned, like, I work for Gradle, so I don't know if I want to pick on Gradle, but there are certain things that we spend a lot of time on that don't necessarily add loads of value to our day job. Like, we want to be writing the core of the matching engine. We don't want to be fiddling with the build script that gets it deployed, right? So sometimes it's nice if the AI can do that. However, there's also, and I'm going to use Gradle as a specific example here as well, I have had not great experiences getting the AI to generate the Gradle build scripts, because they're trained on the data that's out there in the world. And a lot of the data that's out there in open source projects or in pet projects and on GitHub or whatever are either outdated, old-fashioned ways of doing stuff, or just plain wrong. And so often the AI is generating bad code because it's just been trained on bad data.
Yeah. That's totally different I've seen as well. So we're recording this in July 2025, so no doubt by August 2025 it's all going to be entirely different again with AI. But I'm definitely seeing that it's possible right now to start to generate high quality modern services that are cloud native, but in platform engineering, the tools aren't there yet.
Mhm.
That's simply because there isn't enough high quality Terraform scripts out there in the world for the AI to steal and to learn from. So I can totally imagine that being true of Gradle as well, and other build tools where like industrial strength usage of the tools is probably proprietary and owned by companies, and the open source scripts tend to be a bit noddy because that's all they need to be, and that's all I would
Yeah.
do myself.
If you think about this, the sort of code that I put on GitHub, a lot of it is like demos. And
Yep.
I don't code in my demos the way that I would code in real life. I don't
totally.
necessarily do TDD. I don't
Yep.
necessarily have like full integration tests or a good build script. So, and on top of that as well, if you think about the amount of Java code that's in a small, simple application versus the amount of build script code, you still have a lot more Java code to learn off than the few lines of build script code. There's just some things that the AI is not going to be as good at.
Yes, and what will then happen is companies will have to spend more time themselves then training the AI on how they do build scripts. And I think that comes back to, I think the way to AI is going to inevitably create a lot of code, a lot of services that after a period of time, people look at and go, this is too hard to change, let's rebuild. But then now the cost of rebuild has come down like super dramatically. But you'd only be really confident doing that with a non-deterministic system if you've given it really strong guardrails. And that comes back to, what does good engineering look like for your company? What does good technical alignment look like? I've worked in companies where there are really strong technical values where people will say, this is exactly how we do domain-driven design. This is exactly how we do microservices, I don't know. And I've been in other places where it's quite anarchic and it's really up to individual developers, teams ostensibly, but it comes down to the individual. And again, if you think about the rocket fuel analogy, AI is going to make that situation really bad.
Mhm.
And
Early in my career, I worked a lot of places where, especially anyone who's kind of willing to hire a junior developer and like fling them at the code base, a lot of those places, I don't think they would know what a design pattern was if it hit them in the face, you know. And my skill in the first 5 years of my career was very much in taking the big ball of spaghetti and like figuring out where to put a random line of code to make it do what it was supposed to do. And I didn't even know what a design pattern was, and I didn't know what coding best practice was. I knew what unit tests were, but we didn't have any, you know. So yeah, places like that, I can imagine their big ball of mud getting bigger, faster, but just like you said, the rocket fuel thing, just accelerating the path that they're on to a state of unmanageable, unmaintainable, unchangeable code much faster.
yeah, and I worry a little bit about the future career pathway for a junior developer. I also worry about it for an expert developer. I can't make my mind up if we're going to have a world that's full of juniors like feeding the machine, or we're just going to have the machine doing its own thing, and then when it breaks, you call on an expert. I worry about the reductionism in that conversation in my head, but we do seem to be kind of leaning towards that. And in both situations, there is going to be some really hard to change code, some really difficult to maintain services. The thing that kind of interests me at the moment, and I've not seen this yet, but I'm confident it will happen, is when you're creating a service with an AI and it's poorly trained and there's a lot of tech debt in there, it's really hard to change. Like when it breaks in live and you're having a live incident and you look at the code, and not only is there tech debt, like it's just impossible to read, it's impossible to understand. Like how do you even begin to diagnose the incident when you didn't actually write the code yourself? You know,
Yeah.
that whole idea of let's get the most knowledgeable person into the instance so they can understand what's going on. There's going to be a lot of people learning code on the job in like super time pressure situations, and I can imagine incidents being more complex. I can imagine them going for longer. I can totally imagine that situation where people are trying stuff that you probably wouldn't try if you had written the code yourself, and you could actually make the incident worse. I've not seen that yet, but we really can't be too far away from that.
I totally see that. I spend a lot of time thinking about troubleshooting test failures, troubleshooting production problems. And I'm thinking back to the early days of working in these big balls of mud that didn't have unit tests and didn't have any sort of documentation. And what you did is just stick a whole bunch of system out println lines to figure out what on earth is going on. And also you find that when you're debugging code that way, even if you're just putting a println in, you change the behavior. So if you're talking about asynchronous systems and, timeouts and waits, as we found when we worked at LMAX, just putting in even a log message changes the behavior of the system.
Oh, yeah, totally.
And so your race condition doesn't happen anymore. And you're like, what just happened? So I agree. I can see troubleshooting becoming very difficult. Particularly, we all know what it's like when we read someone else's code. It's not great when we read someone else's code. If we read an AI's code and it hasn't been perhaps had the right guardrails put in or vetted the way that we would like to vet it, then we don't even know if the variable names mean anything, or if they say something like order, but it's not actually an order. And it's only when it breaks in production we go, what is this code?
Yeah, totally. And it's when you're pairing with an AI, it's a junior and an expert at the same time. Like there's this really strange thing where it's like a very confident. I can't remember the name of it. That curve where you start out and you're like, well, I know nothing. Now I know everything. Or now I know nothing again. It's always at the top of the curve. Like I know exactly what to do. Follow me. And you're like, I don't want to follow you. Like, the last time I followed you, there was a fire. Like, what are you thinking? And then suddenly it's like, you're absolutely right. I have cocked this up. Well, you didn't have to do this though. Like, just chill and say when you don't know something.
Yeah, it does stuff so quickly. I heard someone say another analogy, which it might have been you, I don't know, but someone said it's like an extremely well-read junior programmer. So
I don't like that. I would put most junior developers I've worked with in my career, I'd put them ahead of an AI just in terms of just that healthy skepticism. Just that okay, well, I'm not quite sure what I'm doing here, so I'll put in some log snippets. I'll make this thing more observable. I'll ask for help. Like I think I did a video recently for the channel about legacy code, and I think I ended on saying something like, just have empathy for the people who came before and what they did. That's like a core engineering skill. Like the AI does not have empathy or sympathy for what happened before. It's just blazing another trail, and it is going to be hard for people to understand. Even thinking about basics, like if we regenerate a service from scratch and then we commit a load of changes to trunk, the diff is going to be really significant. And the reason that you want to do those small incremental commits is that so when something goes wrong, you can actually diagnose it really quickly by saying, okay, so this commit involved 2 lines of code changing. So it's somewhere around this part of the system. If it's one jumbo commit, that's the complete opposite of what we'd recommend in continuous delivery.
Yeah.
And I don't know how we're going to get around that. I predict there'll end up being some very clever tooling that doesn't exist yet around an AI VCS or something where it actually scans through the code compared to the previous version and then tells you what the diff actually is, rather than saying everything's red and everything's green because you rebuilt the entire thing.
I never thought about tooling that could help with that. I remember when I was at LMAX, I had to debug a performance problem, and I spent because we had the performance testing, and there was like a big spike in things taking a lot longer. So we could see, because our performance tests, if you remember, they didn't run on every commit. They would run on every 12 commits or something like that. And so I was doing one of those, what's it called? Like the binary search for with the Git. You give it to Git commits, and you can get it to I can't even remember how it was. But anyway, we're searching through each of these Git commits to find out which one is the one that caused the performance problem. And then you look at that commit to see what's inside that commit. And I can't remember what the problem was, but the main thing was trying to narrow down on a specific commit. Once I found the specific commit, it was fairly easy to find what the line of code was, because we did used to do small commits. Now, what we're working on at Gradle at the moment is we're trying to think about the impact of AI on the continuous delivery pipeline. And we were thinking about this sort of large commit thing. And it's just the way that we work right now with the tooling that we have right now. It's just so important to do small batch sizes, because it's the only way you can really figure out what happened at this point. Which tests went green when this commit was made? What changed? Did the performance spike, or all those kinds of things? So I think right now with AI, I think it's more important than ever to follow some of the best engineering best practices. So have some guidelines, some design guidelines, have some preferences in the way that you develop stuff, have naming standards, commit in small commits, commit to main, have tests, lots and lots of tests, and have tests that run quickly so that you can get that feedback fast. I feel like AI is just making it even more important for us to do all the right things for software engineering, not less important.
Yes, that's exactly what I'm seeing at Equal Experts and with our customers. I think good engineering matters more than ever. And I think that people who take shortcuts and do large commits and do long-lived branching and do all kinds of other bad stuff Like they're going to end up in a world of hurt because, again, of the rocket fuel thing. It's going to 10x all of your problems as well as 10x all of your successes. So I would definitely be thinking really hard right now about how can I work in smaller batches, and how can I do things differently, and how can I augment what I'm doing. Like if anyone's feeling a bit uncomfortable about using AI as an engineer, then just use it as a pair. Just use it to augment yourself. Don't use it to like replace yourself. I can totally see working in a live incident where the code's generated by one AI and you're asking a second AI, what happened here? And the second AI is like, oh, that first AI is a clown, don't listen to it. And then you run back to the first AI. That second AI says you're a problem. First AI goes, no, I'm not the problem. The other one's the problem, which is exactly what would happen with people. And I've seen that situation before in the old days. I think that the technical debt thing is inevitable, but there are ways to mitigate it. And like we've said, in some areas, it's probably going to be okay. It's going to be okay in your trade reporting gateway as long as your tests are green and the orders that come into the trade reporting gateway result in the correct reporting going out to different consumers. But yeah, don't put it everywhere. Don't put it into like a super high performance component of your overall system that's actually really crucial to your business.
Anything which is business critical just needs a lot more human oversight on it.
Yes, and I think that there's a really interesting analogy here. So years and years ago, Martin Fowler wrote something really good about strategic software versus utility software. Mm-hmm. It's on the martinfowler.com website. And I think that that's going to become more important than ever now, because what you'll end up saying is if the technology in an area is a differentiator, then you're going to want humans augmented by AI. If it's a commodity thing, if it's a utility thing, then just let the AI generate it and then let's crack on, because there's not a lot of value out there. It's glue. I think the real way to test that is it something that a product manager really cares about? Is it something they are asking about, or are you reminding the product manager, oh, we have to build this thing actually? And is it something that ideally you would buy and the thing doesn't exist? So the easy analogy I always use is in retail, you need to have a search service on your website, and in the background you need to have some kind of stock service that talks to background systems and can tell your website, this is how many sofas of this color we have in stock right now. In the search case, to a retailer, that is business critical. That's where a lot of revenue comes. You're going to want humans working on that augmented by AI. The stock service, like ideally you buy a SaaS solution. If it doesn't exist, then generate it. That's not something you're going to put your Trishas on, your absolute best engineers on, right? You don't need to. That's not where they can have the biggest impact. And there's not a lot of value out there. It's glue. So I predict, you know how Trish, when serverless started, the way it really started, people were saying, oh, use it for glue. Don't use it for your business critical stuff yet. Mm-hmm. I predict that a responsible way to lean into AI generated services will be do it on the glue stuff first of all, and then gradually inch your way towards more business critical stuff. But there's always going to be some parts of your system that you absolutely want humans building.
I think that's a really good way of putting it. I never thought about it in terms of the buy versus build argument, but I have the buy versus build argument with developers all the time. And, it's like, if you are a trading platform, don't build the HR system. Like, that's just not an important thing for you to do. But now we're talking about buy versus build versus like outsource to the AI. So that's kind of in the middle ground. So I think that's quite a good way of thinking about it.
I wanted to build everything at the start of my career. Absolutely everything. I was like, we can do better than that, we can do better than that. And now that I'm later on in my career and I'm much closer to senior folks and also to how work is funded, you'd be amazed how many things I say, can we please buy this? Can we do this? Can someone just make this thing go away, please?
Yes.
Just really try to bring focus on what's really bringing value out of the business, and let's engineer the hell out of that thing.
Exactly. And I think that one of the things that I've learned as I've become more senior is it's actually not the cost of building the thing, it's the cost of maintaining the thing. Do you want 10% of your software engineering team maintaining your HR system forever? No, of course you don't. That's insanely expensive. Just buy it and pay a service contract.
Yeah, totally. And we're now moving to a world where AI is going to force us to not re-examine those beliefs, but apply them to a broader field. And to return to the retailer example, do we absolutely need to maintain a stock service if the cost of regenerating the thing is much smaller than the maintenance cost? There's going to be some interesting way. People will invent stuff also to handle the amount of tech debt. It is going to be a problem for companies. I can totally see agentic AI resulting in some very different ways to do observability, for example. I can imagine some very clever code analysis tools emerging. that are super duper AI powered. Something like Code Scene with, it's so nice seeing that the Code Scene folks are thinking about that.
We're doing some stuff. Gradle, we're about to release a new thing in Develocity, which is failure grouping. So that when you've got 55 unit tests failing, you don't have to go into each individual unit test to find out what went wrong. It'll group it and go, 50 of these are failing because you've got a JDBC error. And you're like, oh, well, probably I forgot to start the database. That kind of thing. And that's all ML, and that's where some ML and AI stuff can really help us.
Yeah, ML's kind of got lost. When people say AI now, I replace it with Gen AI in my head. I went to a conference last year where someone said, we're doing all this amazing AI stuff at our company. Everybody was like in raptures. And then 10 minutes in, I thought, oh, this is a machine learning tool of clever marketing.
Anyway, we should probably wrap this up. So we're supposed to answer the question. The question is, will AI create mountains of technical debt? So, in summary, what were the sort of the main points that you covered in your answer?
Do we have to answer the question? Like, how much trouble we get in with Dave if we don't answer the question? Like, he doesn't know where I live. Like, and you don't live in the UK. Like, is he really going to find us? Let's not answer.
I mean, he won't find us and hunt us down, but it's helpful for the people watching the video.
All right, fine. Yes, it's going to happen, and it's going to be okay.
Yes.
So I've completely broken Betteridge's law there. What do you think the answer is?
Yes, it is going to happen. And I think for me, the answer, which is part of my confirmation bias, is we should just do software engineering properly and better. And that will help mitigate some of these risks.
Yes, what you said.
Great. Okay. Well, then that's the answer to our big question for this week. Do check out the video that Steve mentioned, which is, it was called What is Legacy Code or something similar.
Yep.
I mean, sometimes when they get posted on YouTube, they come up with different titles.
Yeah. And Emily Batch also has a video, doesn't she, about how to handle technical debt, which I've watched and is really good.
Yeah, exactly. So there's some great videos on this channel to go into each of these topics in depth. And also, I always like to recommend Kent Beck's Tidy First book, because there's loads of things in there about like how to think about managing change.
Yeah, that's a good book.
Cool. Thank you, Steve, for answering our one big question. And I think we should say goodbye to our audience. Goodbye.